Hi guys, and welcome back to a new video. In this video, I will give you a full guide on the Realm database, which is a variable alternative to our already known Room database we like to use for Android. And in many aspects, Realm is actually the better database. So we'll first go over what Realm actually is and how it compares to Room. So we'll go over its advantages, its disadvantages, so you can also get a feeling for which kind of projects Realm might be the better database for and which projects Room might be better suited. And after that, we'll already dive directly into practice and build our little demo app that I have prepared for you here. And that won't be just a very simple database. I intentionally chose a little bit more complex database here that isn't just a single table of nodes or so. No, we will have multiple different kinds of relations here as well, so you can also directly learn how that works with Realm compared with Room. In this case, we will just work with sample data since that's all you need to learn in order to use Realm. So as you can see, we have a list of programming courses here: Kotlin programming made easy, Android basics, and asynchronous programming with coroutines. So with multiple courses in our database, each course is held by a teacher. So you can see held by John Doe, and Jane Doe. Then each course can have multiple students who are enrolled in that course. So here you can see enrolled students, John Jr., Jane Jr., and here both John and Jane Jr. And last but not least, if we click on a course, then we get to see the address of the teacher. So you can see John Doe Street, and so on. And we can also delete this entry, so you can also learn how deletion works. So in this course, you will learn all the CRUD aspects of Realm, so how you can create new entries in your Realm database, how you can save new data, how you can read data and query that, how you can update existing data, and lastly, how you can delete data. Like here, if we click on delete, then this entry is deleted. And even if we then close the app and relaunch it, then you will see that it's really persisted here and we don't have this third entry anymore. So what the heck is actually Realm? Realm is a database that is optimized for mobile applications, so for developers just like us. And the company that maintains it is exactly the same company that also maintains MongoDB, as you can see, so Realm by MongoDB. So it's not some kind of random developer who just thought I will make a new database framework. No, that is actually quite a big company that is behind such a database framework, which I think is very important, since that is the library you might use in pretty much any project out there, or most of the projects out there, and then you want to be sure that this is also maintained properly. When it comes to data storage, Realm works differently compared to Room. So with Room, we have an underlying SQLite database where we just store our data in form of tables and relations, and then we can query that with normal SQL queries. Realm does not work like that. Realm saves its data in an object format. That is actually cool, because if we use Realm on Kotlin side, then that doesn't really require a lot of knowledge about databases, since if you know how to work with Kotlin classes, then it will also feel very intuitive to work with Realm objects. And with that, we already come to the advantages of Realm over Room. So on the one hand, I think Realm is much easier to implement and more intuitive than a Room database, even if you have multiple relations. So if you want to implement a Room database, you definitely have to know how SQL works. You need to know SQL queries. You need to know how relations work and how you just come up with a schema in the first place that doesn't only work, but is also optimized and that doesn't accidentally save data twice or so. And when using Realm, it just felt a little bit less error prone to me than Room. Then the next big advantage is that Realm uses a mechanism called zero copy access. And that is just a way how data is actually accessed after queries. And that zero copy access makes Realm usually the more efficient database compared with Room and with SQL databases. Because the thing with Realm is when you are querying data, then you are interacting with a representation that directly reflects the stored data. So there is no really intermediate step of data conversion, which we have with Room, however. Because the way Room works is it's actually something called an ORM. That is just kind of a framework which gets built on top of an already existing database. So the existing database framework is SQLite, but Room is built on top of that. So we actually have an easier life when implementing such an SQLite database on Android. But that means if we query data with Room, then first of all, the SQLite database queries that data and returns all the results just as very raw data, which Room will then still need to iterate over and convert that stored data to Kotlin data classes. And this intermediate step is just not necessary with Realm, because it directly converts the data that is saved on our device in the database to Kotlin representations. And that just usually makes Realm the faster database. The next big advantage of Realm is that it works for Kotlin multi-platform. So if you're building a KMP project, potentially for desktop, for iOS, then you can also use Realm to share all your data logic. Next up, we also have less boilerplate code than Room. room. So if you've worked with room before, you have tons of annotations, you have a database class with more annotations, you will have to implement a DAO, you have to implement all the functions to access your database, and with Realm, that is just a lot less. Next up, which I already talked about a little bit, but with Realm, it's just not so easy to do something wrong because Realm always works with transactions. So especially when you need to work on multiple tables at once and save data that you only want to save if all these write transactions actually worked and succeeded, then with Realm, since it already uses that by default, you can't do that much wrong. But with Room, you can also do transactions, but you always have to keep that in mind that data consistency is achieved. Okay, that sounds pretty positive for Realm, does it? Yes, but there are also two disadvantages or 2 points where Room is definitely on the upper side here. On the one hand is that Room heavily focuses on compile time validation of your schema and your queries. So that means if you implement a Room schema, so just your database, your relations, which table interact with which table, you implement your SQL queries in real SQL code, then Room will already validate that schema and check it for errors before you can even launch your app. So if you can launch your app that implements a Room database and that launching works, then you can be very sure that there is at least no error in your schema and your queries. Of course, these queries could still be kind of incorrect and not querying what you want, but you can be sure that they are syntactically correct. On the other hand, if you mess up something with your Realm schema, then you'll only notice that when your app is already launched and then crashes. And another disadvantage of Realm is that queries just can't be as complex as normal SQL queries, which you can use in Room. So querying complex data in Realm definitely works, so you can also join tables. You have tons of operators you can use in your queries, but you can quickly just hit a wall when things become more complex than that. So for example, if you want to sort your result entries from that query in Realm based on the length of a specific string in that collection, in that table, then that doesn't seem to work with Realm yet, even though that would be pretty simple to do in Room. So just be aware that it can happen if you implement a Realm database, that at some point you might face issues with your queries that you didn't think of before, which you will then have to work around. But other than that, from this comparison, I think Realm is usually the clear winner. Of course, if you have a project that heavily relies on SQL queries, then Realm might not be the best fit here. But if I had to pick one that I use for the rest of my life at this present moment, then it's probably Realm. Alright, now I think you know the theory you have to know in order to use Realm. So let's dive into coding and see how we can now really implement a Realm database and why it's so much more intuitive than Room. I am here in an empty Android Studio Jetpack Compose project, and the only thing that I've already added is the dependency for Realm. So make sure to add this Realm Kotlin plugin for Gradle and also this dependency here in your Gradle app file for the base library of Realm. But then we can already get started implementing our models. So in Room, that would be one table. In Realm, we call these objects. So one entry of a table is one object in Realm. And for that, I want to go to our root package and create another package called models, in which we define our database schema. And I've already teased that a little bit in the demo app that we will build here, but I think it's best if I go over it again, how our different tables are wired together. Forgive me if I say table here, because I think that's just what most people are used to when it comes to databases. In Realm, these are not strictly called tables, but I just mean our different collections, our lists of specific objects. So in this models package, let's just start with an address Kotlin class. And that is actually not a data class like in Room. No, just a normal class, which always has to inherit from Realm object. That is how Realm knows what is actually a Realm representation or Kotlin representation of a Realm object rather. And in there, we can then define the properties of that address. But before that, I would just like to go over the schema, how that actually looks like, how our different objects are wired together. So on the one hand, we have an address. And in our case, an address always belongs to a teacher. So one teacher has one address and one address belongs to only one teacher. So we can say we have a teacher collection here, which directly has one address. So that is a so-called one-to-one relation. But then we also have a so-called one-to-many relation. That means one teacher can hold many courses. But if we turn that around and take a look at one course, then that means one course can only be held by a single teacher. That is why we get to a one-to-many relation. One teacher, many courses, one course, only one teacher. So let's just write down our different relations here. On the one hand, we have a one-to-one relation for address. Then we have a teacher one-to-many with course. But then we also got students, which we save in our database. So if we take a look at one student, how many courses can one student actually join? Well, multiple courses, of course. And if we take a look at one course, how many students can be in one course? Of course, also multiple. So that is where our many-to-many relation comes from. So students, many-to-many with course. So one student can join many courses, and one course can contain many enrolled students. So that is the schema of our 4 tables that we will work with here, just that you know how to implement all these different types of relations. And the first relation we work on is this teacher to address one. So we first define the fields that make up an address. In this case, I want to save the full name here, which you can argue about if that really belongs to the address or rather to the teacher. But since I want to make an address here unique, I want to put the full name directly in the address table, since only then it's unique, because 2 teachers could potentially live at the same address, but only one teacher can live at a specific address if we include the name of the teacher in the address. It's really just a sample, so we have a one-to-one relation here. And here in Realm, we also always need to initialize these fields. So in Room, the Room plugin would kind of populate these fields under the hood after an SQL query, but here we need to initialize these with empty fields, so either null values or just empty strings, null as an integer or whatever. Then next up, what makes up an address is of course the street, also a string. Then we do have our house number, which is an integer. Let's set that to 0 initially, and we will set these fields manually all by ourselves later on. You will see how that works. Next up, we do have a zip code, which is just an integer, also set to 0 initially. And we want to have a city the teacher lives in. And the way relations work in Realm is that if an address always belongs to a teacher, we can also very well include that teacher directly here in this address object. So we can have a teacher, which we don't have yet, which is a nullable teacher. And that way, if we have access to only an address object, we can directly read the associated teacher with that object. As you can see, it's pretty easy to create such an object. And there is almost nothing specific to Realm here, apart from this Realm object and actually a primary key, which we would also need, except for this address table or this address object here. So normally the way this would work is we would have a primary key here, primary key, which is pretty much the same as with Room, which we create. In Realm, that's usually called _ID, since that's also the name of the ID parameters that we have in MongoDB. And since it's from the same company, I guess it's the same kind of convention here in Realm as well. And that's also not a string or an integer like in Room databases usually, but a so-called object ID. You can see that comes from MongoDB. And we can set this to a newly initialized object ID, which will just generate a new random string ID. It's not just a completely random string, but it actually also contains timestamp information, so information about when this object was created. So you theoretically wouldn't need to store this as an extra field if you want to, for example, sort your resulting entries of a query based on when they were created. But the thing in this case is, because one address always has an associated teacher, and there is never an address that isn't associated to a teacher, and that teacher will have a unique ID, we don't really need an ID here for the address object itself. So we can remove this. And what this also means is that this address won't just be a normal Realm object, but rather an embedded Realm object, because we will take this address and we will directly embed it into the body of our teacher object. So we will never save this address just alone, but always in combination with the teacher. And since the teacher will then have a unique primary key ID, this will also automatically count for an address, because the same address will never belong to multiple teachers. So if we now go on and create our teacher class in our models package, that is our Realm object. Since we don't want to embed this teacher anywhere, no, we only want to embed this address into our teacher object. And here we now need this primary key ID, var ID, which is an object ID and set to a nearly generated object ID by default. And well, what does belong to a teacher? On the one hand, we now have an address. Each teacher has one address, so include that here. That is nullable by default. We will set that manually later. And apart from an address, a teacher does not have any individual fields. Only one more thing, and that are the courses this teacher is actually holding. So var courses, which would normally just be a list of course. We also don't have a course class yet, like an empty list, for example. But if we do it like that, Realm doesn't have any information about how to kind of link a teacher and a course, because we don't want to just save a list of courses here, since that would just not give Realm enough information to later on link these different classes and objects to perform some queries on, for example. So what we instead want is, instead of a normal list, we want a realm list. So that is just the specific data type for lists that Realm uses internally to also model these relations if one teacher has multiple courses. And then we can also not set this to an empty list by default, but we need to set it to a realm list of. You can see there's also a realm set. So if you have a list where each item is unique, then better use a realm set, since that's optimized for these use cases, which would actually be quite a nice use case I'm just noticing here, since one teacher wouldn't hold the same course twice, so we would include that same course twice in that same list. Here you could use a realm set of, but I prepared the project with a list. It's the use case is just pretty similar, just that a set is optimized for unique entries, while a list is not, and a list can contain duplicates. Okay, what comes next? Let's go to our models and now create our course class. That will also be a realm object. And in here, we again, first of all, need our primary key, var ID. Since each course has a unique ID, each course is unique. What else fields does a course have? Well, obviously a name for the course, which is an empty string by default. And a course has one teacher that belongs to it. So we can also include our teacher reference here. Teacher is teacher, and that's nullable and null by default. But apart from that, a course has one more thing, and that is a list of enrolled students. And that at this point is nothing new, since a list of enrolled students is again just a realm list of student, again a class we don't have yet, and that's just a realm list of. So let's create the last class here of our schema by going to models, new class called student, hit enter, call that realm object again, have a primary key per student, var underscore ID, object ID, and a new object ID. Then each student obviously has a name, just like a course. So we create that property here. And now one student could be potentially enrolled in multiple courses, while one course can also have multiple students that are enrolled in this course. So here we are now dealing with a so-called many-to-many relation, which we didn't have yet before. And you might now think that we now also just have a var enrolled courses, for example, which again is a realm list of course in this case, is equal to realm list of. That is the first thought you might have here, but it actually works a bit differently, since that would mean that for each student, we save the list of all enrolled courses. And if we have two students who are both enrolled in the same course, then that would mean we would save this course information twice for each student. But it's actually enough to have one reference to the same course, which both students are enrolled to, and then just link these together when we need that when querying them. So instead of this realm lists, the way such many-to-many relations work with realm is, we instead have a realm results of type course in this case, so multiple courses which we are enrolled. And then we say by backlinks, and we refer to the kind of foreign property of the course table in this case. So to course, enrolled students. And we also need to make this a val since we're using the delegate. So that just means for a course, we just save the list of students who are enrolled in this course. But for each student, we don't need to save that information twice. So we just create kind of a backlink and link to these already saved courses in this case. So we can still include that information here for each student. And as you can see, that is now our whole schema that we have in Realm. We just have an address, we have a teacher, a course, and a student. So in Room, these would be 4 tables. And in Room, having to link all these together would be quite a pain. You would have tons of annotations. You would need an additional relation table because you have a many-to-many relation. You will need to store foreign keys, so the foreign IDs if you have a one-to-many relation. And all that is just stuff you have to know before being able to use Room. You have to know this theory in SQL development. But I think Realm is just much more intuitive here. And with that little code, we already built our whole schema. Okay. Let's next take a look at how we now instantiate our database reference. So in Room, that works by having an abstract class or an abstract class for our DB that inherits from Room, that database or so. And in there, you then need to reference your DAOs in which you define how you can access this database. In Realm, that again is easier. So we just want to have an application class, my app, make this inherit from application. And I'm just using this application class because I don't set up any dependency injection here with the Dagger Hill, for example. If you would do that, then you would just have your database reference created in your Dagger Hill module and then inject that wherever you need it. But here, let's just have a companion object so we can access this database reference from all over our project with a late init variable for realm, like this. And then we override onCreate, in which we initialize this realm database. So in this case, realm is equal to realm.open, where we have to pass a configuration. In our case, this configuration is pretty much just telling realm what kind of schema we want to use with this database reference. So we say realm configuration.create, and the schema in this case is just a set of, you can see, realm objects. So we have a set of, on the one hand, address, double colon class, we have teacher, we have a course, and we have students. And we just created our database reference, and now we can refer to this in our activity by just accessing myapp.realm. So let's now next learn about how we can work with that database. And for that, I'll create a little view model here, main view model, make that a new class, make it inherit from view model. And in here, we will just reference our realm database. Private world realm is equal to myapp.realm. And in order to actually refer to this myapp, we also need to register that as application class. Let's quickly do that in our manifest. And here in this application tag, we say Android name is myapp. Okay, so let's think about what kind of functionality we need in order to use this database. The very first thing we need to do before we can think of anything else is, of course, being able to write to our database. Being able to create some sample entries that we can then read, that we can then update, and that we can then also delete. So first of all, private function, create sample entries or so. And realm is completely based on Kotlin, so it also uses coroutines and flows under the hood, which is pretty cool. So let's launch a coroutine here in viewModel scope in order to write something to our realm database. And here we say realm.write. That is really how this works. This write function will open a Lambda block here, which gives us access to immutable realm, so our immutable version of our database kind of. And all database actions, all database writes we perform in this block are now executed as transactions. So this whole write thing in this block will only be executed if all these single write transactions actually succeeded. So if, for example, we already inserted an address, a teacher, and a student, but then our device is kind of out of memory or so it can't save the associated courses, then realm would revert all of that, since it wouldn't make sense to insert just a part of our query while leaving out the rest since it failed. And the way this now works is we really just go in here and create our objects. So first, let's have one address. Address 1 is a new address, and then we can call apply to set these fields. For this first address, let's give this a name of John Doe. We then need a street of, let's say, John Doe Street. We need a house number of something like 24. We need to give this a zip code of, I don't know, 1, 2, 3, 4, 5. And we need to give this a city of John City. Then we can copy this, or actually make this a val first, since we don't need to mutate this. Copy this, paste it below, have a second address for our dear Jane Doe. Have a Jane Doe Street, house number maybe 25 next to John, and rest is the same. What we can't set yet is the teacher reference here in our address, since we haven't created these teachers yet. But that is why all these are actually mutable properties inside of the class, so we can still update these later when we then have the teacher reference. But before being able to create a teacher, we want to create a list of courses that are offered here in our little app, so we can also directly associate these courses with the teachers we will create right after. So val course 1 is in this case a new course, again call apply. Give this a name of Kotlin Programming Made Easy, for example. And then here we can't yet set the teacher reference, and we also can't yet set the student's reference, since we also didn't create these yet. So we copy this course 1 twice. So we have a second course and a third one. This one is Android Basics. And this one could be asynchronous programming with coroutines, something like that. Now that we have our courses, we can create our teacher references. So val teacher 1 is a teacher.apply. Then each teacher, you can see, needs an address and a list of courses. So the IDs are always automatically generated, so we don't need to set these on our own. But each teacher now has an address. So this teacher 1 has address 1, and the enrolled, or actually, how's it called? Just courses. The courses are a realm list of, let's say, course 1 and course 2. So let's say teacher 1 who belongs to address 1. So if we take a look, oh, that's John Doe. So John Doe teaches Kotlin Programming Made Easy and Android Basics. Let's also do this for teacher 2. So teacher 2 belongs to address 2, so that is now Jane Doe. And since teacher 1 already teaches the first 2 courses, and one course is already taught by one teacher, we can't let Jane also teach these same courses. So Jane would now need to teach course 3. And now that we have these teacher references, we can also update the references in our objects before. So our address still needs a teacher and the courses also. So we go below, we say course1.teacher is equal to teacher 1. Since our teacher 1 teaches course 1, then our course2.teacher, well, what is that? Also teacher 1, since the course 2 is also taught by teacher 1. And the course3.teacher is in this case teacher 2. So that one is taught by our teacher 2. That is something with Realm you actually have to take care of your own, that the schema works. So if we would do something like this here, for example, then it would actually break because our course 3 isn't actually taught by teacher 1. So you need to take care of that on your own, but I think this would cause a crash at least during runtime when you then launch your app. But it doesn't do that in compile time as we get that with Room. Okay, so what's the last thing that's missing here? We have addresses, we have courses, we have teachers. Well, we obviously also need students. And one thing before is actually that we also want to update the addresses. Just let's do that before. So we have our address 1, that teacher is teacher 1, and address 2, that teacher is teacher 2. But now we can create our students. So while student 1 is a new student, call that apply on that, give these a name. So this would be John Jr. And let's just copy this. This one would be Jane Jr. like this. And each student also has a list of enrolled courses. So we can make this a realm list of, oh no, actually in this case not, because in the course class we are using the enrolled students, and in the student class we use the enrolled courses, which actually isn't just a list, but it's a realm results by backlinks. So for each student, we actually don't need to create a list of the enrolled courses, but rather have a list of enrolled students for each course. So let's remove this again, go below here now that we have our students, and say our course 1 that enrolled students, which is now a realm list, .add, and here we add our student 1. So we say our John Jr. student is enrolled in our course 1, so in Kotlin Programming Made Easy. If we then go ahead and say our course 2 is actually has the student 2, which is Jane Jr. in this case, and then we can say our course 3 enrolled student add, and here we can now, let's say, add a list of students of student 1 and student 2, and actually use add all here, like this. So that says, hey, both student 1 and student 2 are enrolled in asynchronous programming with coroutines. Only student 2 is enrolled in Android Basics, and only student 1 is enrolled in Kotlin Programming Made Easy. So that is how these many-to-many relations work. And the backlink of our student class will then take care that we can automatically refer to this enrolled courses object here when we have a single student. So all that is managed by Realm itself. So what we did so far is what Realm calls an unmanaged format. Unmanaged means we have Realm objects, so our course, our teachers, our addresses, and our students, but these are not yet persisted in our Realm database. So if we would execute this write function as it is, then all these objects would be created, but these wouldn't be saved. So if we then close our app and open it again, then our database would be empty. In order to now take this unmanaged format of these classes and put that into a managed format, which means it's managed by our Realm database, we need to copy these to our Realm database. And that works with the copy to Realm function. So you can see the instance needs to be a Realm object, which we luckily have here for all of our objects. On the one hand, our teacher 1, let's add our teacher to Realm. And you can also see that we can pass an update policy. So if updating goes wrong here, for example, if you add a teacher with a primary key that already exists in your database, then by default, that will throw an error. because each primary key needs to be unique in a realm collection. But what we can do here is we can pass an update policy of update policy all. That will mean if we actually have a teacher object, and this teacher object has a primary key that already exists in the database, what realm will do is it will update all fields of that existing teacher object in the database with the new teacher objects. So by doing this, you automatically also already covered the update mechanism of your database, since updating just works by reinserting an object with the same ID of the previous object, just with the different fields. And that is what we want to do for all of our copy to realm functions here. So also teacher2, and just copy this, do this for our courses. So course 1, course 2, course 3, and we do this for our students as well. Student 1, student 2. We don't need to do this for our addresses, since one address is always part of a teacher, and if we save the underlying teacher an address belongs to, we automatically also save the address. So now you've learned how you can write something to a realm database, so completely new objects. You've learned how you can update existing objects in a realm database by just making use of this update policy. Let's next take a look at how we can read these entries from a realm database, so we can also see if this really worked. We can do this by going up here and defining something that should now query our courses table, because if we have one course, then all the other data we save in our database is associated with that course. So if we know a course, like here, then we definitely know the teacher of that course. If we know the teacher of the course, we know the address of that teacher. And if we know a course, we also know the enrolled students. So with just one reference to a course, we know everything else that belongs to that course. So what we want to do here is we just want to query all courses in our database. If we go to our main view model, we can do this by having a private val, actually not a private val, but a public val, since we want to access that from our UI later on, called courses. And that is equal to realm.query. So this is how we can define queries. And let's use this query overload here, since that allows us to pass a generic type of the items we expected to return. If we don't pass any specific query here in form of a string, I will get to that later, how these queries work. If we don't pass that, it'll just query all courses in that course collection. And if we then take a look, these courses is now a realm query of type course. So we still need to convert that to a format that our UI can actually work with, which would ideally just be a list of courses. And something Room also offers us, which is pretty cool, is that it returns our results as a flow so that we can react to changes in our database. And that is also what we want with Realm, and what Realm luckily also supports. So we can take this query results, convert these as a flow. You can see that now returns a flow of results change of course. And we can then take this flow and map it to something else. So we get each results change here. So this map log will now trigger whenever anything in our course table changes. And we can then take these results and map that to the results list, which is now a realm results, and just convert that to a list. And that now gives us our actual list. So this is now a flow of list of courses. And since we would like to persist that as a state, which caches the latest course list, let's also use the state in operator, cache that in view model scope, pass sharing started while subscribed. So this will listen to all these queries and changes as long as there's at least one subscriber. So as long as our UI listens to that. And the initial value will just be an empty list of courses. And that is how we get reactive changes to our course list. So we now have a state flow of list of courses, which we can then listen to in our UI and easily convert that to compose state. So if we go to our main activity, here in our surface, we can first of all create a reference to our view model, private val view model, which is a main view model, and we say by view models, like this. Then here in our surface, we get a reference to our courses state, and we say by view model that courses collect as state. Normally you would need to use collect as state with lifecycle here. That requires a different dependency though, and for the sake of testing, this is completely fine here. So now we have our list of courses as compose state, and with that we can update our composables. So we want to have a lazy column to display this list of courses, assign a modifier to it, modifier fill max size, and we say we have a vertical arrangement of arrangement that's spaced by 16 dp. I'll enter to import dp, So that way we just make sure that there is 16 dp of spacing between each list item. Then we can say we have an items block with a list of t, and here we pass our courses list. Then we get a reference to each course, and for each course we now want to just show such a course item, which just shows the course title, shows the teacher who holds that course, and shows a list of the enrolled students. And if we click on that course, we will also see the address details of the teacher. So let's go down, have our course item here, which takes in a course reference for which we want to display that, and an optional modifier. Starting with a column, we want to pass in our modifier here, and then we have a text for the course name, so course.name. We then want to also assign a font weight, which is bold for this course title. We want to assign a font size of 20 SP to just make this a bit bigger. Then let's have another text for the teacher who holds that course, course.teacher, and actually let's make this a string, held by course.teacher, like this. And the teacher itself is just a Kotlin object, but we want to show the name of the teacher. So we can say .address, .full name. And this, I think, is really the cool thing about Realm here, that we can just have our objects behave like normal Kotlin objects. We don't need to perform any complex joining like with SQL databases, where we join multiple tables in one result format, which we then again need to map to something in order to use it. So it's much easier to just work with these collections and objects by using Realm. Then for this text, I would like to remove the font weight, set the font size to something like 14 SP, and set the font style to italic, like this. Then let's have some spacer below, modifier height of 8 dp. And last but not least, we want to have a text for all of our enrolled students. So we have enrolled students, colon, and here we want to iterate over all of our students and just put a comma in all of their, between all of them. So instead of referring to the teacher, we refer to the enrolled students. We say join to a string, and we join them based on the name. So the join to string function, as you can see, will just iterate over these enrolled students and put a specific separator in between, which by default is just a comma. Let's make the font size 10 SP, remove the italic formatting, and that is our very basic course item. Let's now use this here by passing in our course reference we get in the lazy column, and by passing in a modifier of filmax with first of all, then let's have some padding of 16 dp, and we have a clickable modifier since we later on want to be able to click on that to just show the address details of a teacher. Right now, we don't have the functionality for that in our view model yet, but that should be enough in order to see if inserting into our database actually works. So again, in our review model, let's close these Gradle files. We have this create sample entries function, which we of course need to call here in init, create sample entries. And then we listen to these in real time with query as flow, mapping these to a normal Kotlin list and saving that as a state flow. So we cache the result in memory, which we can then easily listen to in our compose code and display these results in the lazy column. So let's launch this on our device and also open this here. So my running devices tab is here. Let's open this, attach my phone, and that is still the old app. There we go. It actually crashed. Okay, let's take a look why that happened. I'm going to logcat. Only subclasses of Realm object and embedded Realm object are allowed in the schema, but we found the address one. But I thought that we made this embedded Realm object. So we have our address, which is an embedded Realm object, but it tells us that isn't. So I don't know what went wrong here. We could, of course, just try to launch this again. I assume that won't change anything. No, it crashed again. So I'll need to inspect this and then I'll get back to you. And just when I stopped the recording, it came to my mind, of course, I forgot to apply the Realm plugin in our app Gradle file. So let's just go to our Gradle project level file, copy this ID, go to our app level file, scroll to the very top and apply this here. So the Realm Gradle plugin just wasn't active, wasn't generating classes. So it couldn't recognize which of our objects was actually a Realm object and which wasn't. Let's relaunch this again, give this another try, and take a look. There we go. Now it doesn't crash anymore. And you can see we have our Kotlin programming made easy, Android basics, and asynchronous programming, and all the data that is stored here seems to be completely correct. And also if we now close our app and actually, first of all, go to our view model so we don't insert these entries again, let's comment these out and relaunch this, then that should persist and we should be able to still see our data. Yes, that is what happens. So we have a completely normal working database mechanism here. And now that we have that, the next thing I would like to go over are some basic queries. So how we can now query that data, because right now in our view model, we are always querying the whole data set of all of our courses. But what if we now just only want specific courses? Then I, of course, can't go over all different types of RAM queries here, since that can become a little bit more complex, not as complex as SQL queries. But if you're interested in that, I will link this documentation down below for the RAM query language, since that is different than the one we know from SQL and also different from the MongoDB query language. But you can go down, select Kotlin SDK here, and then you will notice how this works. So all the different queries, you can see that is how such a query could look like. You have dot notation, comparison operators, logical operators, how to work with strings, dictionaries, list comparison, with backlinks, all that kind of stuff. So if you don't know how to query something in RAM, this is the place where you'll find the answer. If you're unsure, you can also just download this page here as a PDF, feed that into ChatGPT and ask it to give you answers based on that documentation for your specific query. For now, I just want to go over some very basic queries, not necessarily very basic, but just some examples so you get a feeling for how that could work. So if we take a look here, let's say we only are interested in the courses where our John Junior student is actually enrolled. So that would be the first one and this, the third one, but not this Android basic one. You can see here's only Jane enrolled. So what we could do is in this query function, we could define this query predicate and we just query that. So the courses based on the fields we have in these courses. So in a course, we have the name, teacher, and enrolled students. In this case, we're interested in the enrolled students. So we can say enrolled students.name, so the name of each student, needs to be equal to something, needs to be equal to $0. That is how Realm works with arguments, just to prevent SQL injections, I guess. So we need to have these parameters here as $0, $1, $2, and so on, depending on how many you have. And then you specify the actual placeholders or the actual parameters that we want to insert for these placeholders just right after here with this var arg. So here we could ask for John Jr. So we are interested in all courses where the name of the enrolled students is equal to $1, and it will take the first argument here to insert it for that. So where the name of the enrolled student is equal to John Jr. And if we now relaunch this, and take a look here, then you can see we only get 2 courses, and those are actually exactly the same as I mentioned before, John Jr. and John Jr. here, but not the one where John is not enrolled in. Another query could be an aggregation query, so where we basically loop over our courses and then aggregate all of these together in a result, or aggregate at least a subfield of a course. So what I mean with that is we could go over our enrolled students, say point at count greater than or greater than equal than 2. So we only get those courses where the enrolled student count is at least 2. If we launch this, take a look here, then we only get this course which has 2 students, but not the other ones. Or we could go ahead and say, we want all courses where the teacher address, that full name, contains the word $0 again. Then we say, okay, John, for example. So we want all courses where the teacher contains the name John. If we relaunch this, then now we only get those courses which are held by a teacher that has John in their name. So I think this gave you an impression of how these Realm queries work. Again, if you want specific use cases, check the docs below, ask ChatGPT, and you will quickly find an answer. And just as a last thing, we want to learn about how we can delete courses from our list and also show the address details of our teachers. So I want to go in here, have a var course details, which is a nullable course reference by mutable state of and null by default. Alt-Enter to import that delegate, and make this a private set. So that course details field will just be the course we have selected, where we open the little dialog with the address details. If it's null, no dialog will be shown. If it's not null, then the dialog for that corresponding course will be shown. So then we need a function in our view model to show course details for a certain course, where we just say course details is equal to course, and we need a function to hide course details, where we just say course details is equal to null. Let's then create a little ugly dialog in our main activity down here. So below this lazy column right here, we want to check if viewModel.course details is not equal to null. So that means we opened some course details. If that's the case, we want to show a dialog on dismiss request where we viewModel : hide course details. So when we tap outside the dialog, then we will hide them. And in here, let's just create a little column, assign a modifier of modifier dot within 200 dp, 300 dp, for example. So somewhere in between 200 dp and 300 dp, depending on the screen size. I want to clip the corners of that a little bit based on our rounded corner shape of 10 dp corner radius. Then I want to color the background a little bit based on our material theme. Color scheme surface, and last but not least, have some padding of 16 dp. And then inside of this column, we want to show our whole address for a specific teacher. So viewModel.course details let to get the details here, which we need in order to show the address. Actually, we could also already refer to the teacher here. So we get the teacher reference, not the course details. And then we can also refer to the address of that teacher by saying teacher.address without a question mark, and then have 3 texts here. First one is teacher.address.full name. Actually, we don't then even need this address field, and we could say address here immediately and refer to the address instead. So we're going to say the first text is address.full name, and then the second text will be address.street plus a space and address.house number. The third text is address.zip code plus another space and the address.city name. And since the zip code is an integer, we can't concatenate these strings here as we want. So we need to first convert that to a string, and then that works. And below all these texts, we want to have a button. And when we click that button, we want to call our view model delete course. So we will delete the currently opened course. We can also color this button a little bit by saying colors is equal to button defaults, button colors. And we say the container color is equal to material theme, color scheme, error container. The content color can be material theme, color scheme, on error container, like this. And then the text of that button will obviously just be delete. And then we can go on this delete course function, Alt-Enter, and create this member function in the view model. And in here, we can then now learn how we can delete a course reference. So viewModelScope.launch, that is again an asynchronous thing. And since we want to mutate our database again, we need to refer to realm.write. And first of all, we get a reference to our course details, or just a course we want to delete, which is our course details. And if that's null, we want to return at write, since then we can't delete anything. And you might now think we could just call delete with a deletable. So a deletable would also be a realm object, so something we can delete, which of course is definitely. That would compile, but it wouldn't work. Instead, what realm wants from us is that we get the latest course by saying find latest based on this course. And that could also be null. We want to return at write. So this find latest function will just avoid that we want to delete a course reference here that isn't actively saved in the database anymore, because it could be that another thread deleted this course in the meanwhile before this function can actually finish. And this is just a mechanism that Realm uses to avoid running into such race conditions, running into such inconsistency states in our database schema. So we first need to refer to the latest course with find latest, and then we can pass this latest course here, so the correct details also get deleted. Then we can say Course details is null, so our dialog will be hidden again. And I think that should suffice for now. Let's relaunch this and take a look how this works. Minimize this. There we go. We have our content programming made easy. If we click on that, we get to see no dialog. Didn't we show this here? So we have course details is null. Course details is course, which we didn't call yet. Obviously, in our main activity, we prepared this little clickable function where we now need to call viewModel, show course details for our course we're currently looping over. Relaunch this. Take a look. And did this crash? This really crashed. Why is that crashing? I think this is really just a Gradle bug here because it's complaining about the same thing again with the address. So we might just want to clean rebuild. And maybe that didn't even happen to you. So let's just quickly rebuild this project. And after that, we can launch our app. And yes, there we go. If we now click on this first entry, we see our address of that teacher. Everything seems correct, John City. If we click delete, then our reference is deleted. Since we listen to these changes in real time, we don't need to load this from the DB again, since Realm does that automatically for us, since we use the flow there. If we click here, we also see Jane's details. We can delete this. And just to show you that this is really deleted, we can close this app, reopen it, and you will see that all these courses that we deleted previously will really be deleted and they disappear from our list. So if this database is really interesting to you, then take a little look in this video's description and you will be surprised how much more interesting premium courses I have there for all of you who want to become really industry ready and advanced Android developers out there. I have a course for pretty much any topic you could imagine or that could be important for the industry. So take a look there, and I would also be very interested in your opinion about Realm. Have you used that before? Will you use it in future again after this tutorial? And how do you like it compared to Room? Let us know that below. And other than that, thanks so much for watching. I will see you back in the next video. Have an amazing rest of your week. Bye bye.